This is chapter 5, extension number 3, where we're going to look at polynomials of this form now. Not only x squared plus bx plus c, but now we have a factor of a in front. Okay? This is probably going to be the hardest part of chapter 5's extension, so please pay attention well. So let's just do the first one. We're going to expand. Expand means, once again, to get rid of the brackets. So just like what we did last day with FOIL or the distributive property, I want us to do the same thing today. So go ahead. What's 2x times 4x? 8x squared. Good. What's 2x times positive 5? That's right, 10x. What's negative 3 times negative 4? X. Negative 12x. And then negative 3 times 5 minus 15. Notice, once again, we have 4 terms, but the 2 in the middle could combine together. So we'll combine like terms now. 10 minus 12. That's negative 2x, and there is your final answer. All right? So, can you try part B and C on your own? Okay. Press pause then. And remember, math people like to have things written in decreasing degree order. So the highest degree power goes first, the 14y squared. Then I'll combine the y's together. There's negative 41 of them. And then also plus 15 as well. Okay? All right, now part C. Remember, this is the one where many of you would think, oh, I'm just going to distribute the square. No, don't do that. Ah! What you really want to do is just rewrite this out as 3a plus 2 times 3a plus 2. And when people do that, there are no problems. 3a times 3a is 9a squared. 3a times 2 is 6a. 2 times 3a, 6a. 2 times 2 is 4. 9a squared plus 12a plus 4. Done. Okay? Now, remember how expanding and factoring are inverse processes? So now, let's use algebra tiles to help us factor the following. Notice in the first question is 2x squared plus 7x plus 3. There's my 2x squared. Here are my 7x's, and there are 3. Remember, our goal is to rearrange it into a nice rectangle. So we always start with the x squares in the top left corner. There are 2 of them this time, so I'll just go with 2 like this. And now our job is to distribute the 7x's. Okay? I'm thinking, I don't know, we're just going to try. I'm going to put 1 here, 2 here, right? Maybe I don't know, a third one here, a fourth one here. Okay, now keep that in mind that we need 3 in this corner, right? So 4, maybe I'll put 1 down here. 5, and I put another one down here. That's a problem because look, that's already 4. That's way too many. So maybe it's just 1 of them down there. 5, and then I have 2 more. Oh, maybe I'll put them here. So there's our 7 x's, and oh, this is great because now we have space for exactly 3 small squares. Perfect. So my answer, here's my x. 1, 2, 3. This is just x plus 3. And my answer here, 1x, 2x with a 1. 2x plus 1. So ultimately here what we just said is 2x squared plus 7x plus 3 is now equivalent to 2x plus 1 times x plus 3. Bam. And that's how you can use algebra tiles to do this. Okay? Now, it's the same thing for the other ones, so let's try them together. Okay, 2x squared plus 7x minus 4 this time. Start with my axes. Start, of course, with x squared in the top left corner. This time, whoa, you're thinking, how come these are negative? Everything's positive, so what do we need? We have to have at least 1 0 pair, don't we? Okay, so think about adding in some 0 pairs because we need a negative rod of x. So let me just add in 1 and see what happens. Here, that means we have 1, 2, 3, 4, 5, 6, 7, 8 positive x's and 1 negative x. Okay, and we have 4 here that we need to go in this corner. So think about that. 8 positive, 1 negative. Hopefully you're thinking, the 1 negative probably goes here. Good. And then 8 positives split amongst hopefully 2 of them. You see that I get now 4 in each, right? And I think this is good for us, because look what happens in this bottom right corner. Perfect. Now we can put the 4 red negative 1s. And there's my perfect rectangle. Okay? That means my answer at the top here, 1 rod of x, 1, 2, 3, 4. And then down here, 2 x's with that's right, negative 1, so 2x minus 1. So ultimately here, 2x squared plus 7x minus 4 is equivalent to 2x minus 1 times x plus 4. And once again, we can always double check by asking you to distribute, and then your answer should be the same as what you started with. Okay, last one. You fiddle around with this one, and you'll come back. Alright, so this is 3x squared minus 11x minus 4, and you go ahead and try it out yourself. Yes, once again, press pause. Don't cheat. Now remember, you're probably going to need some zero pair again, because I see negative 1, right? Negative x times negative x is positive, so we'll probably need at least one of these. I don't know if we need more. We'll find out soon enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. Well, that's kind of nice, because I have a group of 3, so I can distribute this among there. Alright, sorry, these are actually negative. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. My zero pair, don't forget that positive one. And this is perfect, because now once again I have just enough space for those 4 ones. Dun, da, da. X 1, 2, 3, 4, all negative, so x minus 4. X with a positive 1, so 3x plus 1. Here we go, 3x squared minus 11x minus 4 is equivalent now to 3x plus 1 times x minus 4. There you go. Now, you're thinking, do I always have to draw pictures to do these factoring questions? No, but the pictures hopefully help you see what's going on. And now I'd like to show you some algebraic techniques that mimic the pictures so that you can visualize what's going on. Okay? Well, not visualize, but actually find an algebraic way that doesn't take as long. Okay? So, how can we factor these polynomials of this type? Okay? By the way, this is a big note, so you should actually highlight this. Note, always factor out the common factor between the 3 terms first if they exist. And we had examples like that in the previous extension. Okay? These ones are where you cannot factor out anything. Okay? So, here is the question. Factor 3x squared minus x minus 10. And you're going to do this 3 different ways. Okay? First one, we're going to call it logical reasoning, or just guessing and checking. We know that the trinomial when factored is 2 binomials. So really, you should ask yourself, what 2 binomials multiply to give you 3x squared? And you can also ask yourself, what 2 numbers add together, or multiply together, sorry, to give you negative 10? And I want you to write them down in 2 columns. So we're just going to randomly guess. I'm just going to guess what 3x times x, right? And then for 10, how about 2 and 5? But wait, it's negative 10, so I'm just going to guess, I don't know, make this one negative. Okay, so we wrote them down in 2 columns like this. Now the idea is to multiply diagonally. So if I take 3x times 5, what do I get? Well, that's 15x, right? And then I see x times negative 2. That's minus 2x. So I multiply diagonally, and then check to see if the sum is the same as the middle term. So if I add this together, that gives me 13x. Is that the same as the middle term? Uh-oh, it's not. So therefore, oops, I have to try a different combination. So let's try this again now. I will once again do 3x and x. Maybe this time I will reverse it around. I don't know. I'm just going to put 5 and negative 2 here. So let's see what happens when I do the multiplication diagonally. 3x times 2, that's negative 6x. 5 times x, that's positive 5x. And now if I add them together, negative 1x. Well, that's exactly the middle term. I'll say, yay! And then now, the issue is, what are my factors? So what are my factors? Well, in this case now, since we found the right combination, the factors are actually the groups in rows like this. So the answer is 3x plus 5, and also x minus 2. So we do diagonals to find the middle term, but we do horizontals to find the factors. Okay? And we can always check this by expanding, so I will quickly check now. Let's quickly expand just for fun. 3x times x is 3x squared. 3x times negative 2 is negative 6x. That's positive 5x minus 10. And lo and behold, that does work. It is the same thing. So I know this is the right answer. Okay? That's what I call logical reasoning. Yes and check. Just finding different combinations, multiplying diagonally, and then checking to see if the sum equals the middle term. Okay. If you think this one's too, like, magical, then let me show you another way. Okay? Now, there's actually 2 other ways, and options 2 and 3 actually start the same way. Okay? So this is called decomposition, and the other one's called choose method, but they both start the same way. So the idea is when you are factoring, you need to find 2 numbers with the sum of b. Now that sounds similar, right? 2 numbers that add to the middle term, just like what we did last day. But now the difference is the product has to be not just c, but c times a. Okay. So for our question here, once again, the question was 3x squared minus x minus 10. Notice we're trying to find 2 numbers that multiply to not just negative 10 now, it's negative 10 times 3, so negative 30. And the sum has to be equal to negative 1, the sum of the factors. Okay? So you ask yourself, what times what gives you 30 now? You can list them out. 1 and negative 30, negative 1 and 30, and so on and so forth. But because I know that the sum has to be negative 1, I'm predicting that those 2 factors are pretty close together. And the closest ones together are 6 and negative 5. And then you have this combination, right? Negative 6 and positive 5, and that gives you negative 1. That makes more sense. So once I found the correct factors, your goal is to split up the middle term. Here are the correct factors. So split up the middle term. So watch what I mean by that. So 3x squared minus x minus 10. I can split that up into 3x squared minus 6x plus 5x minus 10. Notice that negative x got split up into negative 6x plus 5x. Okay, that's what they call decomposing or decomposition. And then it says, can you factor by grouping the terms? So I want you to look at the first 2 terms, call that one group, and the last 2 terms, call that another group, and ask yourself, what is common amongst that first group here? 3x squared minus 6x. I hope you can see there's a 3x that's common. Dividing everything by 3x, you'll get x, and then 6x divided by 3x is minus 2. Then over here with 5x minus 10, I see a common factor of 5. I'll take that out. And then look at what's left over on the inside as well. X minus 2. Now this is great because the stuff in the factor or in the bracket should be the same. And if it is the same, now you can say, hey, amongst these 2 terms, what's common is the factor of x minus 2. So I'll take that out. And what's left over will be the 3x and the 5. And there you go. You factored this. Exactly the same as above. Okay. Now this way is a little bit more methodical. It might take a little bit more work, but you know, if you like a step by step, this is good. Now, let me show you option number 3. Option number 3 is called choose method. If you don't know who Chu is, neither do I. But he came up with this method, and it seems to work. but you're thinking this method is kind of weird because you're like, what's going on? So let me just show you how to do it, and then I'll show you then why this method works. Okay, I don't want to just show you something and say it works. So, idea is the same. Find two numbers. Oh, I should write down the question first, right? So 3x squared minus x minus 10. Okay. So once again, find two numbers that multiply to negative 30 and add to negative 1. Okay. So ask yourself, what's the combination? Just like the previous question, we found it was 6 and 5, negative 6 and positive 5. Good. So here's what we do. We use the idea just like how we did before with the factors of x squared plus bx plus c. So we write it like this, x minus 6 and then x plus 5. So just like the previous lesson. But here's the new thing we have to do. We have to divide each term by a and simplify. So now each of those numbers has to be divided by the variable or the factor of a. A in this case is the number in front of the x squared term. So each of these have to be divided by 3. Okay? And you're like, why? I know, but let's just do it. This then simplifies to x minus 2. The factor here, x plus 5/3, cannot be simplified, but I can make it look a little bit nicer by just taking the 3 and moving it up here, because I'm multiplying both things by 3, and I'll just get 3x plus 5. And with choose method, boom, there's the answer as well. Okay. So the key thing, the weird part here is, once again, don't forget to divide each number by the a value, then simplify if possible, and then if you see a fraction, the idea is to move the denominator up. I call it bottoms up. Okay. Now, the question is, why does this work? So let me show you a proof. Okay. It's really just an idea of substitution. So we started with 3x squared minus x minus 10. Here's what I want us to do. Multiply by 3 and also divide by 3. So if you do that, notice what happens. 3 times 3 is 9, so 9x squared minus 3 times x minus 30, and we're going to divide that by 3. Okay. Now here's a note. Remember, 9x squared can be written as 3x all squared. So if that is the case, I can rewrite this as 3x all squared minus 3x, I'm going to put a bracket around there and hopefully you'll see why, over 30. Remember how we did those really tricky, challenging questions last day? That's why, because now I can use this idea of letting a equal the stuff in the bracket. Look at this now. A squared minus a minus 30 over 3. Do you see how that top is really just now an x squared plus bx plus c kind of question, like what we did in the previous extension? And then you can be asking yourself, hey, find two numbers that multiply to negative 30 and add to negative 1, right? That's from here. But that's exactly what I asked you to do up there. We found the correct factors, a minus 6, right? A plus 5. And then notice here we're dividing everything by 3, right? But we're not done yet. Recall that a was originally 3x. So now we'll substitute back in 3x. So now we have 3x minus 6, 3x plus 5, all over 3. And now, look. A factor of 3 I can take out. Why is that helpful to take out that factor of 3? Look at that. And look at this. Same answer as above. Okay? Wow. So, what I've done now is shown you all these different ways. I need you now to practice, okay? Practice, practice, practice these, and factor with whichever method you are comfortable with, okay? I'll tell you what I like. I like choose method because it's very similar to the previous one. So I'm going to use that throughout. I think it's the quicker way. But once again, if you like decomposition, I think that's good too. Many teachers use that. And then if you like guessing and checking, that's working too. It's really up to you. Whatever floats your boat. Okay? Alright. I'm going to look at choose method. I think two numbers that multiply to 36. Those same two numbers add to 20. 18 and 2. Looking good. X plus 18. X plus 2. Now with choose method, remember we have to divide by the a value. So each of the terms get divided by the a value. Then you need to simplify. And that 2/3 we can rewrite as 3x plus 2. Bottoms up. Done. Okay? Try this one on your own. Once again, two numbers that multiply to what? 12 times -2. Same two numbers add to -5. There we go. So x minus 8, x plus 3. Don't forget now to divide by the a value. And then now here you're going to have to simplify first. So that becomes 2/3. That becomes 1/4. And then now, bottoms up. 3x minus 2. Bottoms up. 4x plus 1. Done. Okay. Part C. That's right. The combination is two numbers that multiply to -20. Add to -12. And by the way, you should be trying this on your own and then just double checking my answers. I've done enough examples for you. You should be actually practicing this on your own now. Okay? You can think a minus 10, and then because there's a b squared, yeah, you got to put a b there. A minus 2b. Divide by 4. We'll simplify a minus 5b over 2. A minus b over 2. And then once again, finally, bottoms up. Bottoms up. 2a minus 5b. Bottoms up. 2a minus b. Done. Okay. Now for D, E, and F, the only difference now, remember I always said to you, is to factor out the greatest common factor first. Okay? So, factor. Okay? Two things multiplied to -30. Those same two numbers add to -7. Think of the right combination, 10 and 3. Yes, so D plus 3, D minus 10. Don't forget now, what are we actually dividing by? Now, it's not this a value here, careful, it's this one, the factored form, right? Because you're actually factoring 2d squared minus 7d minus 15 now. And then, once again, bottoms up, and simplify. Done. Okay, the last two are yours, and yours by yourself. Okay, and I think this video is already quite long, so I'm going to stop it, and then I'll do another one with the challenging factoring questions. Alright, so do E and F yourself, and then we'll stop. This stuff is not easy. You need practice, and you need to do this well. Because once again, I'm going to use this again in grades 10, 11, and 12. Press pause. Find two numbers that multiply to 30, add to 13, I think. Divide by the factor of a. Bottoms up. Simplify. Done. And for f, I think you can take out a -2. Two numbers that multiply to -60. Those same numbers add to +7. Yeah, it's 12, but notice this is m to the power of 4, so if I split that, it must be m squared. Divide by the a value. Simplify. Bottoms up. Done. That's it. Okay? Like I said, I'll make another video for the challenging factoring questions.